But first, let's talk about testing. So this new model was deployed at CSU's METEC facility during the ADED campaign this summer, and results are just coming out now. So it ran in our production environment in real time for the full 13-week controlled release program. This was a blinded study. We submitted our predictions without knowing the ground truth, and then afterwards, we were able to compare directly to the actual emissions. As many of you know, I think the METEC facility is meant to simulate an oil and gas facility, and while it's not perfectly representative, it's still an excellent environment for assessing how well the entire system performs, right from the hardware to the model. So this year, they dramatically dialed up the complexity. What you're seeing in this animation is just 1 hour of controlled releases sped up. So they maintain similar complexity for the full 13 weeks with 10 of these low rate emission sources running almost continuously. You can see on the left and right there, those were basically constantly running. And these were intended to simulate combustion slip. And so then they mixed in periodic higher rate releases also from other leak points across the facility. In total, there's about 24 of them. And so these long-running low-level emissions, they contributed almost a third of the volume that they released this year. But the actual release points were only emitting at about 0.1 kilograms an hour each. So they really stress tested the limits of what you can do with a fence line system. So the chart on the right just shows how complex the release scenarios were. More than 90% of the time, there were 11 or more simultaneous emission sources. So it's essentially a worst case scenario for this disentangling of overlapping plumes, and really a stress test for the multi-source model. So we published our results in a blog post recently, if you want to dive deeper, and there's more to come soon, more analysis, but here's a representative 2-week period. So the top plot is showing the ground truth emissions, and below you can see the Qube predictions. And what's remarkable is how consistent the performance was. We can look at any 2-week period and they all look very similar. So we reliably identify high rate individual events, and we accurately captured both their rates and durations, even with all the background complexity going on. Here we break down the performance into 3 buckets, all looking at emission rate on the x-axis. So on the left, the blue bands are showing ground truth versus predicted rates. And you can see the 1-to-1 line there. And so our predictions generally fall within the 1 sigma accuracy. So that's what the blue lines are representing, is 1 standard deviation away from that, away from our predictions. And so we generally fall within 1 standard deviation, and it's often quite a bit tighter. In the center, we're showing a fraction of 15-minute periods in which emissions were correctly identified. So we have a blog post kind of talking about probability detection and time to detection and how those link. But this being a 15-minute period, it means that even on that left side with a 40 or 50% hit rate in a 15-minute window, this actually corresponds to something more like a 90% probability of detection if you're looking at hour-long time spans. And then obviously beyond that, those higher rate emissions were almost 100% detected. And then the right plot, this shows our cumulative predicted versus ground truth emission volumes, and this is grouped also by it's all grouped by total group release rates. And so you can see how much of that total volume was emitted in those lowest rate bins. And so you can see how challenging those conditions were for our system as well. And so those previous charts were all shown grouped by the source groups. But if we look at the individual source rates, so each source, what was it emitting? And all of those combustion slip sources that we talked about, those are all emitting at 0.1 kilograms an hour. So this is well below what we would probably advertise as our minimum detection limit, and probably for any fence line system, to be honest. So these low rate emissions, they accounted for a third of the total emitted volumes. And so when we include all emissions, we actually under-quantified by about 30%. But what we're showing here is if you filter out emissions and only show emissions above 0.2 kilograms an hour, our quantification accuracy for the entire 13-week period was within 5%. So every technology has a minimum detection threshold, and above that threshold, Qube system quantified extremely accurately.